lesson with slope. And we're going to identify slope as a rate of change today. So we're going to connect slope to a rate of change. Now when you think about rate, you think about like mile is to hours, cup is to day, dollar is to month, or whatever. It's a comparison of two units, right? And slope is a comparison. It is the change in y over the change in x. Always. Slope is always change of y over change of x. Don't ever flip it, okay, because that's not commutative. So, that's that. Let's say Myrtle drives the same number of miles to and from work each day, as shown on the graph below. Okay, got it. This is Myrtle's driving to work graph. So here's my y. My y is top. So this is my y, miles. Days is my x, right? X is on the bottom, y is on top. So I want to know, let's use this graph to calculate her rate of change. Okay? So pick two perfect points on the graph. Found it. You don't have to pick those exact ones. Actually, just so you know, you don't have to. I'm just going to pick something different. I'm going to pick this one, and I'm going to pick this one. It does not matter. What matters is it's two perfect points. Now, analyze slope. Slope is change in y over change in x. So be careful for scaling today. You have to be so careful for scaling. Notice I don't go up 1, I go up 10. So it's 10, 20, 30. My change in y is 30. My change in x, looks like I'm going a half a day each one, right? There's 2, 2.53. So this is 0.51. 30 over 1. Yeah, it's 30 over 1. Because look at your scaling. You better be careful for that scaling. My scaling on the x-axis is by 0.5. So be so careful with your scaling. 10, 20, 30 over 0.51. I'll just show you that's the same thing if I used these 2 points. Rise over run. 10, 20, 30 over 0.51. 30 over 1. Okay? So, based on the graph, what is the unit rate of miles per day? So remember, it's, whoops, I want you to write this kind of lingo. Y over x. You always talk about your y first when you describe something. It's always y. Slope is rise over run. Okay? So my y is miles. 30 miles in 1 day. That's a real life application of myself. Also known as unit rate. It's your unit rate. Slope is unit rate. Here, maybe you should write that down. Slope equals unit rate. Okay. Today was interesting. I got a lot of questions from last hour. I mean, there were hands constantly in the air, analyzing tables and stuff. Remember, when you are comparing slope, you find two perfect points, and when you look for the description, whatever y is has to be talked about first. For example, you will be given things that say, hey, is it 30 days per mile? So really, they talked about x first, y second. You can't do that. It's y over x. You always have to have y first, okay, when you talk about rate of change. Okay, so the next one. The table below shows the cost of grapes in the produce aisle at the grocery store. We have pounds and cost. Well, money depends on pounds. So y is the money. Y is always what depends on the other thing. X is independent. That can connect you to the science fair too when you talk about independent and dependent variables.
That's over now.
Money is dependent on how much you buy, right? The cost depends on what you get. So I want to use this, what's the price per pound? So that's saying dollar is to pound. That's what it's saying. Change y over x. So change in y over change in x. Looks like my y is always changing by 4.30. And it looks like my x is always changing by 2. Am I right?
Yeah.
Yeah, I'm right. And then I gotta simplify. So 215? 215 is to 1? So that means that it's $2.15 per pound. Someone last hour says, well, why can't I just divide it? You can. My goal here, you can always do what works best for your brain. However, my goal here is to connect slope to unit rate. It is the same thing. Slope is a unit rate. It's that constant change that keeps going on. And in summary, remember again, you always put y before x. It's always y over x, or change in y over change in x. That's your learning target.